Welcome back to AI Talks with Chris and Nita. Ready for another deep dive?
Always.
Awesome. So we've been getting a lot of questions about Gaussian process regression and
GPR, yeah.
GPR, exactly. It can seem kind of intimidating at first, but it's a really powerful tool, especially if you're working with, continuous data. And when the relationship between your inputs and outputs, it isn't always clear.
Right. It's perfect for those situations where you're like, wait, what's going on here?
Exactly. So let's break it down, make it a little less mysterious. What exactly is a Gaussian process? Could you give us like the plain English version?
Sure. Think of it this way. Imagine you've got a bunch of data points, right? And you're trying to figure out how they're related, like what's the underlying pattern. Now, instead of just drawing a single line through those points, a Gaussian process gives you a whole bunch of possible lines. Each of those lines has a probability attached to it, like how likely it is to be the true relationship.
So it's not just about finding the best fit. It's about exploring all the potential, connections.
That's it. And that's really powerful because it gives you a much more nuanced view of what might be happening.
I can see how that would be useful. So you're not just getting one answer, you're getting a whole range of possibilities and how likely each one is.
Precisely.
Okay, now I'm starting to get the big picture. But let's get a little more specific, shall we? What about this mean function I keep hearing about? What's that all about?
The mean function, it's like your starting point. It represents the average trend you'd expect to see in the data.
Okay. Could you give me an example?
Sure. Let's say you're trying to predict house prices based on their size.
Okay, yeah.
The mean function would basically say bigger houses tend to cost more.
Right. That makes sense.
So it's the general rule of thumb, but then the Gaussian process goes beyond that. It looks at all the variations around that average.
Okay, so it takes the basic trend and then explores all the little ups and downs, the deviations from that pattern.
You got it.
Cool. Now, I've also heard about this covariance function, or something's called the kernel function. What does that one do?
So the covariance function, or kernel, that tells you how much you expect the output to change as you move between different inputs.
So, if we're talking about stock prices, a good kernel function would say, okay, prices tomorrow are probably going to be similar to today's prices, but not necessarily the same as prices a month ago.
Exactly. You nailed it. The kernel function captures those sorts of relationships, those dependencies in the data.
That seems like a pretty important piece of the puzzle then, wouldn't you say?
Oh, it's absolutely crucial. Choosing the right kernel function is like half the battle.
Because it determines how the Gaussian process, understands those relationships.
Exactly, yeah. But the good news is a lot of that fine-tuning is actually handled automatically through something called marginalization of hyperparameters. It's a mouthful, but it basically means you don't need to be a statistics whiz to use GPR effectively.
That's a relief.
Right. It does a lot of the heavy lifting for you.
So that's good news for, everyone, really. Anyone who's just getting started with this stuff.
For sure. So before we get too far, we got to talk about prior and posterior distributions.
Okay, those sound kind of,
A little technical.
a little bit.
I know. But they're super important in Bayesian statistics, which is like the backbone of Gaussian process regression.
Right. Bayesian statistics. So what are these distributions all about?
Okay, so the prior distribution, that's basically what you know or what you assume about the function before you even look at any data.
Okay. I'm trying to guess how much a used car costs, and my prior would be older cars are usually cheaper.
Exactly, you got it. And then as you start looking at actual data, prices of different cars and their age and all that, you update that initial belief, and that becomes your posterior distribution.
So the data kind of refines my initial guess.
It's like evidence, right? It helps you paint a more accurate picture.
I like that, yeah.
And that posterior distribution, that's where the magic happens. It tells you not just one possible answer, but a whole range of functions that could fit the data, along with their probabilities.
Oh, so it's like giving me options, these are the possible scenarios, and here's how likely each one is.
Yeah, that's a great way to think about it. It's like having a map, but instead of just showing you the route, it shows you all the possible routes and how likely each one is to get you where you're going.
That's way better than just having one route, especially if there's traffic or road closures.
Absolutely.
Right.
And that's why GPR is so good for making decisions, especially when things are uncertain.
I see. Okay, so we've got the mean function, the covariance function, and now the prior and posterior distributions. How do all these pieces work together in Gaussian Process Regression. Can you connect the dots for me?
Sure. So you start with your initial guess, right? And then you bring in the data. And through this process called Bayesian inference, the data kind of interacts with your prior, like they're having a conversation.
A data-driven conversation. I like it.
And the result of that conversation is the posterior distribution, which is a much more informed and nuanced understanding of the function.
So it's like the data is telling the prior, hey, you know what? You were a little off here, but you were pretty close there.
Exactly. And then that posterior distribution, that's what you use to make predictions about new data points.
Okay. It's all starting to click now. And on that note, we'll wrap up this episode of AI Talks with Chris and Nita. Thanks for joining us, and we'll catch you next time.